In this next one here, we're looking at the number of the time driven and the number of miles driven, and we want to find the rate of change. Remember, rate of change is just kind of the application of the slope. It's the same thing. So when we're looking at slope, we're talking about the change in y over the change in x. And so rate of change is the same thing. And so as I look at this thing, I just compare how these things are changing. So in other words, I look at the pattern here. So here I look at the pattern and say, hey, this is going up by 2, and then up by 2 again, and then up by 2 again. That's how the x values, that's how the time is changing, okay? And then we do the same thing with the y values. This is going up by 102, and then here it's 102 again, and then here it's 102 again, all right? And so as I look at the way the x is changing, I look at the way the y is changing, the rate of change is the ratio of those things changing. So right here, the ratio here, sorry, that's a little big. The ratio for this one would be 102 over 2. And the ratio for this one would be the change in y, which is 102, over the change in x, which is 2. And the ratio here would be 102 over the 2. See, I'm comparing this guy over this guy. And I do that for each of these changes in order to determine the rate of change. Because what happens is if this isn't the same each time, in this case it is, it's 102 over 2 each time, which is 51. And so it's the same each time for this one. If it's not the same, then we can't identify a rate of change because this isn't a linear equation. So I've got 51 here, but then we also want to interpret that. It's 51 what? Well, that's miles compared to hours, so miles over hours, so miles per hour. Okay? So understanding the rate of change from a mathematical perspective in terms of slope, it's also important to understand it from a real-world perspective in terms of rate of change, like something like miles per hour. Okay? If we look at these guys, going back to algebra class and identifying the rate of change or the slope, and so if I look at something like this guy, remember slope, we think about it in different ways. We have our formula, the y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We have change in y over change in x, the way I was just describing it. But we could also describe it as rise over run. And all of these mean the same thing. It's the change in y over change in x is more, probably to me, this is the most generic way to think of it. Because rise over run really is how far up do I go, how far over do I go? How do I change the y value? How do I change the x value to get to where I need to go? Okay. So when we're thinking about a graph, we want to do change in rise over run. And so I just identify points that this thing goes through. It goes through that one, goes through this one, goes through this one. And so as I look to get from one point to the next, I have to go up 1 unit and then over 4 units. And then to get from this point to the next point, I have to go up 1 unit over 4 units. And so if I'm talking about the slope, it's up 1 over 4. And so that's the slope. It's rise over run, which is 1/4. If I look at this one, if I identified some points this one goes through, really, if you think about it in terms of rise over run, we should recognize this right away and say, oh, it's a vertical line. The slope is undefined. All right. But if we look at it from the perspective of rise over run, hopefully you see that the rise is kind of whatever I want it to be. I'll say the rise is 1 to get from one point to the next in terms of those green ones that I labeled. But the run, I don't move over at all, so the run is 0. It's 1 over 0, which I can't do that. If you could try and calculate, it gives you an error. This is undefined. Okay? And all vertical lines are undefined. All horizontal lines, the slope is 0. Okay? And just be careful in terms of your positive versus negatives here. I always go left to right as I count the points, so I only need to decide, am I going up or down? If you go up and then over, it's a positive slope. If you have to go down, then it's negative. Okay? And so think about that in terms of, is the thing increasing as you go left to right, or is it decreasing as you go left to right? That'll help you with the positives versus negatives. Okay? If we look at these guys, it says find the slope of the line that passes through the points, then find the slope of the parallel line, then the slope of the perpendicular line. And so for this one, you could do change in y over change in x. That's my preferred method, all right? But most students, I think, prefer the formula. If you like change in y over change in x, go ahead and do that. I'll do the formula for this one. Remember, it's y sub 2 minus y sub 1, so 4 minus the 1, over x sub 2 minus x sub 1, that's 8 minus the 2. And the keys to this thing are, 1, make sure you do this in a consistent order, all right? If I did this guy minus this guy, well, then I have to do this guy minus this guy. All right, if I do it the other order, if I had done the 1 minus the 4, well, then in the denominator, I have to do the 2 minus the 8. Make sure you subtract in the same order for x as you did for y. Okay. The other thing is make sure y is on top. All right. That's the other thing that students tend to make mistakes with, is every once in a while we mix this up and we do our fraction upside down. Okay. So this guy, 4 minus 1 is a 3. 8 minus 2 is a 6. And then that gives me a 1/2. Make sure you reduce it all the way. So the slope of this thing is a 1/2. But then the slope of the parallel line, remember parallel lines, the slope is the same. So the parallel line would also be a 1/2. And then the perpendicular line, remember, is the opposite reciprocal. So I change the sign and flip it. So if I change the sign, it's going to be negative. And if I flip a 1/2, it becomes a 2. Okay? That's it. If I look at the next one, same kind of thing. If I were to do the slope formula, again, -1 minus 7. If I do it in that order, then I have to do 0 minus a -2. And be careful with the signs here. Remember, subtracting negative is the same as adding the opposite. So here I get a -8 over a +2. That's a -4. So my slope is a -4, which means the slope of the parallel line is also -4 because it's got to be the same. And the slope of the perpendicular line, opposite reciprocal, that's a +1/4. Okay? If I look at the next one, again, 14 minus the 5 over 3 minus the 3. And so once again here, I get a 9 over 0. I can't do that, so the slope here is undefined. The parallel line would also then be undefined because it has to be the same. But then the perpendicular line, this is where it might be a little bit tricky. You can either kind of think of this conceptually and say, okay, the undefined means it's a vertical line. The perpendicular line would then have to be a horizontal line, which means the slope would have to be a 0. Okay? Or go back up here. Go to a spot where you had numbers. Take these guys right here. Change the sign and flip it. That becomes a -0 over 9. Well, it doesn't matter if it's positive or negative because 0 divided by 9 is just 0. That's the perpendicular line. Okay? But look at this one. It asked, does this represent direct variation? Remember, direct variation is our special line that goes through 0, 0. It's in that format y equals kx. And so if I want to know, is this direct variation, I just want to see it if it conforms to y equals kx. So all I have to do is solve for y and see if it looks like that format. So if I solve for y here, subtract the 2x from each side. So y equals, that's a 1/2 x. And so when I look at this, is that in the format y equals kx? Is it a line that goes through 0, 0? And the answer is yes. This one is direct variation. So yes, this represents direct variation. And out of curiosity, the constant of variation, the k value, is a 1/2. We often refer to it that way. Yeah, it's the same as the slope when we're talking about the graph. It really is rate of change in a way, but it has a special name here. It's the k value. It's the constant of variation. Okay. If we look at something like this guy, it says, suppose y varies directly with x, y equals 10 when x equals -3. What direct variation equation relates x and y? And then what is the value of y when x is a -1? And so if I wanted to write the direct variation equation, I just need the k value. Okay. So if I kind of think about this from this perspective and say, hey, y equals kx, that's the format for direct variation. And it's telling me when y is 10, x is a -3. Well, that's enough information for me to be able to find the k value, to find the rate of change, to find the slope, to find the constant of variation. And I do that simply by dividing each side by this -3. So I find out that k equals a -10 over 3, which means the equation, so to answer the first part of this, the equation would be y equals a -10 thirds x, and that's it. Okay, so that's the equation. The second part of this thing asks me to find a value, and I can find that value by plugging it into this equation. So I can say, hey, y equals a negative 10/3, and it gives me an x value right here of -1. And if I plug that in, I get y equals a positive 10/3. So that would be my value for this thing. Keep in mind, though, remember, if you are asked just to find a value, if you're not asked to write the equation, we can do this using proportions. See, that's the other thing that's special about direct variation, is its points are proportional. So we could say this, y over x would be 10 over -3 equals y over x. Well, I don't know y. X is a -1. Okay? So when y is a 10, x is a -3. When x is a -1, what's y? Cross multiply and solve. Okay? And so if I cross multiply here, -3y equals a -10, and then I divide each side, and of course I'm going to get the same answer. But remember, direct variation, the x and y values are proportional, so we can always do it using proportions as well. So those are your two options. When you're trying to find a missing value from direct variation, either set it up as a proportion, just make sure the fractions are set up the same way. Here I did y over x, so the second fraction had to be y over x. Okay? The other option is to find the k value, create an equation, and then plug values into that equation. Okay? On this one, the grade a student makes on a test varies directly. So it's basically saying this is direct variation. Okay? So varies directly with the amount of time the student spends studying. Suppose a student spends 5.5 hours studying and makes a grade of 76 on the test. What is an equation that relates the grade earned on a test, G, with the amount of time spent studying, T. Okay, so grade G compared to the time, T. All right, and so once again, it asked me for an equation this time, which means I need the k value. So I'm going to start off with y equals kx. And really, instead of instead of y and x this time, didn't mean to erase that much. Instead of x for our variable, it told us that time is this variable. And instead of y, we want a test score, which it told us g. It doesn't matter that these aren't x and y, that they're t and g. It's still the same thing, okay? They still would be plotted as x and y if we did this on a coordinate plane, if we did a t-chart, that kind of thing. All right, we're just labeling them differently to match the values we're talking about, grades and time, okay? And so if I kind of plug away on this, it said, hey, 5.5 hours, so 5.5, gave you a score of 76%. So now I can solve for k. I can find that constant of variation. So I divide each side. So I got k equals. And so if I plug this into my calculator to give me a decimal, you can either convert that decimal or, rewrite this guy. You can think of it as something like, this over 55, okay? And then reduce that fraction. If I reduce that fraction, it's a 152 over 11. And so that's my k value. And the reason I want to leave the k value like that instead of writing it as a decimal, I think I forget on the calculator, it gives me like 13.882, something like that. All right. But the reason I want to leave it as a fraction instead of as a decimal is because I want to write an equation. The whole point of equations is that we want this to be very accurate so that I can make predictions later. Remember, we did the same thing with lines of best fit. Okay. So y equals, in this case, we're going to do g equals, the grade equals 152 over 11 multiplied by t. Okay, that is the equation, and we could find out more values. We could say, hey, if I want to get 100%, plug 100 in for g and solve for t, figure out how much studying time you would have to commit. Okay. If I look at this guy, it says table below shows an elevator above ground level for a certain amount of time, and we want to write an equation for the data. And so once again, if we're writing an equation, we have to kind of look at this and say, all right, what's the change in y over change in x? I have to look for these patterns. And over here, it's a pretty easy one. This one goes up by 10, and then here it goes up by 20, and then here it goes up by 20 again. Over on the other side, we have to do the same thing, and so we're looking for the values here. Here that goes up by 18. Okay. The next one, it looks like it goes up by 36. And then this one, it looks like it also, or sorry, it goes down. I've been saying up this whole time, but these are negatives. Let me try again. So down 18, down 36, and then down 36 again, it looks like. All right. And so even though the pattern changes, it's because, well, the pattern for x also changed. The thing we want to see, we want to determine is the same. We want to look at this and determine, hey, is the change in y over change in x the same? And so I have to look at this and I have to say, hey, for this value, it's negative 18 over 10. And here it's negative 36 over 20. And here it's negative 36 over 20. Okay, I'm comparing the values on this end to the values on this end. I'm writing that ratio. And then if I reduce that ratio for each of these, I get the same thing. Every single one of these gives me the same ratio of negative 9/5. Okay, and so that's my slope, and I can call it slope, and I know this is linear because the rate of change stayed the same. Okay, if this guy does not remain constant, if that changes, then this is not a line. The way we determine if this thing is a line is if the rate of change in y over change in x gives you the same thing each time. And here it does. It gives me a negative 9/5 each time. So now all I have to do is I might have to just continue this pattern. And so right here, if I continued the pattern, this is the easiest way to do it. If I put a 0 here for time, okay, if I went down by 10 over here, well, then I would have to go up by 10 over here, which would be 212. That's my y-intercept, okay? And that's the easiest way to do this, is to kind of continue the pattern. So notice we could fill in values in between, like here. I could plug the 30 in and then make this guy go up by 18, or I could plug the 50 in and make this guy go up by 18 and fill in those gaps. And so kind of using this first one, and we would like to think about slope in different ways, but if you use this guy, we'll use that and say, hey, right here, if this went down by 10, well, this one goes backwards and goes up by 18. Okay, so kind of using that slope backwards, and I don't know why I changed it by 10 over here. Sorry, let me rewrite that. Up by 18, that's a 220. I wrote 212 like a crazy person. Okay, well, we're just using that pattern backwards. And so that's my y-intercept, which means I can write the equation of this thing. It's y equals negative 9/5 x, that's the slope, plus 220 would be my y-intercept, okay? That's telling me where the elevator started, okay? If I look at each of these guys, it says find the x and the y-intercepts. Remember, for any equation ever, if you want to find the x-intercept, you just plug a 0 in for y. So here, negative 4x plus 2 times 0 equals 24. And now I solve. Negative 4x equals 24. I divide each side. So I get x equals a negative 6. But now always write this as an ordered pair. That's negative 6 for x, but remember you plugged a 0 in for y. Write it as an ordered pair. It's a good habit to be in. It makes more sense to do it that way, and it'll help keep things straight when you start to graph this, okay? If I want the y-intercept, I just have to plug a 0 in for x. And once again, I solved this thing for y. Write it as an ordered pair. It was 0 for x, and then I got a 12 for y, okay? This guy over here, same thing. If I want to find the x-intercept, I plug a 0 in for y. If I want to find the y-intercept, I plug a 0 in for x. So here, if I plug a 0 in for y, now I simplify. And then solve. I divide each side. And this one I would not do by hand. This one is a job for our calculator. So let me punch that in. 140.94 divided by a negative 2.9. So it looks like I get a negative 48.6. And again, write it as an ordered pair. That was a negative 48.6. That was the x value. The y value that I used was 0. Okay. And now I do the same thing to find the The y-intercept, I plug a 0 in for x. And I continue to simplify. And then solve by dividing each side. And again, this is a job for my calculator. 140.94 divided by the 5.4. Okay, so 26.1. And again, write it as an ordered pair. The 0 was the x value. The 26.1 was then the y value. Okay. If I look at this one, I want to write the equation. This one says, give the equation of the line in slope-intercept form of the line with a slope of -4/3 and passes to the point 3, -3. Remember, slope-intercept form, we typically go right to that if we have the slope and the y-intercept. Those are the two things required for slope-intercept. And so as I look at this, I have the slope, but I don't have the y-intercept. What the problem gave me is it gave me the slope and it gave me a point. And when I have the slope and a point, the good choice for writing the equation would be point-slope form. And it's right there in the title. Point-slope form is used when there is a point and the slope, and that's what I have here. So I'm going to use point-slope form, which is this guy. And I just plug in what I know. I know the slope is a -4/3. And then I plug in this ordered pair. Remember, those minus signs are like opposite signs. So right here, this is an x value of +3, so I have a -3 here. And this one is a y value of -3, so I have a +3 here. Okay? Because the minus sign is built into the formula, it changes the sign of the thing we see there. Okay? And now from here, to put things in slope-intercept form, I just have to solve for y. So I use my distributive property. I distribute this guy. And be careful with the signs here. That's a plus. The 3 and the divided by 3 cancel out. That's a 4. Because remember, a fraction, that's times 4 divided by 3. All right? And now I subtract the 3 from each side. That's it. Slope-intercept form. Okay? But again, you can always write the equation in point-slope form. And a lot of times that is probably the easiest one to get. But then you can always rearrange it from there. Okay? The next one says, give the equation of the line in point-slope form that travels through the point -2, -8, and has a slope of 3. And so we just kind of did this, all right, to start this one. I'm going to use this same format. But again, y and x go here. The slope is 3, and then I plug in the point. But remember, those minus signs give me the opposite. So instead of a -2 here, it's going to be a +2. Instead of a -8, it's going to be a +8. And that's it. Point-slope form, done. Okay, if it asks for slope-intercept form, I would distribute that 3 and subtract the 8. Okay, if it asks for standard form, I'd put it in slope-intercept form, and then I'd rearrange the thing to get x and y on the same side. Okay, this one, give the equation of line... give the equation in slope-intercept form of the line that passes through these points. So once again, slope-intercept form, I don't have the slope or the y-intercept, okay, but I can get the slope. And I'm given 2 points, so I'm still going to do point-slope form, okay? So let's find the slope. Again, if I do my -3 minus the 2 over the 8 minus a -2, that's a -5 over 10. So that's a -1/2, so that's my slope. And now I go to point-slope form. So the slope is a -1/2. And then I can choose either one of these points. I can choose the -2, 2, or the 8, -3. Some students will choose the -2, 2 because the values are smaller. Some students are going to choose the 8, -3 because it's easier to distinguish the 2 points. I'll do that one. Why not? So -8 and a +3. We tend to make sign errors when the values are the same and we keep glancing up. The 2 and the -2 kind of play tricks on our eyes. So if that happens to you every once in a while, choose the points that look that have the x and y values that look a little bit more different than the 2 and the -2. And then from here, slope-intercept form, I have to distribute. It's a -1/2 x plus 4. and I'm going to subtract that 3. So I get y equals a negative 1/2 x plus 1. That's it. But look, at the next one, it says give the equation of the line in standard form that passes through the points 3, 4, and 1, negative 6. And so if I want standard form on this one, it still is giving me 2 points, which will allow me to find the slope. And then I have 2 points, so I can get the slope. I have points, so I'm going to do point slope form. I'm still starting off in point slope form. So here, let's see, it's a negative 6 minus a 4 over a 1 minus a 3. So that's a negative 10 over a negative 2, which is a positive 5. And then from here, point slope form. I like to set it up with kind of these blank spaces, makes it a little easier. So the 5 goes here, and then I can pick either one of these points. If I use the first one, that's a minus 3 here and a minus 4 here. And now I'm going to convert this to slope-intercept form. I'm going to distribute. I'm going to add that 4 to each side. But now from here, if I want to do standard form, remember standard form is the one where we have x and y are on the same side. It's x plus y equals constant. All right, x, y equals constant. So I just have to get the x over on the same side as the y. So I'm going to subtract that 5x from each side. And this is pretty close. This is basically standard form, but remember we have some little technicalities. We're not supposed to have a negative out front, so technically that 5 is not supposed to be a negative. We're also not allowed to have any fractions, but it's easy to get rid of some of that stuff. We can clear fractions by multiplying through by the common denominator. We can get rid of the negative by just dividing each side by negative 1. And really, for all intensive purposes, there's not a situation in which it really matters if the x is positive or negative. When we use this in application types of problems, it doesn't matter. But if you're specifically asked for standard form, technically that's supposed to be a positive. Okay, your teacher might accept the negative 5x plus y equals negative 11. Okay, but technically you're not supposed to have a negative out front. Okay. If I look at this one, give the equation of the line in slope-intercept form that is parallel to 1/4 x plus 2 and passes through 4, negative 9. So once again, it's easy to find the slope. If the slope of this guy is right here, this slope is a 1/4, the parallel line, which is what I'm looking for, is also going to be a 1/4. Okay? And so now I have the slope, I have a point, I'm going to point slope form. As I plug in the point that it gives me, it's a minus 4 here and a plus 9 here. And now it asks for slope-intercept form. Once again, I have to distribute, and then I'll subtract this 9. So I distribute, subtract the 9. Okay. If I look at the next one, we want slope-intercept form again. We want to be perpendicular to this line this time. And so as I look at this thing, this guy has a slope right here of negative 5. But if I want to be perpendicular to that, I have to do opposite reciprocal. That's going to be positive 1/5. Okay? So now I have the slope. It gave me a point here. So I go to point slope form. So the slope here is 1/5. I plug in the point that it gave me. That's a minus 2 here and a minus 0 here. And what's really nice about this one is I don't have as much to do here because y minus 0 is just y. I just have to distribute. That's a 1/5 x minus 2/5. And that's it. All right, if I look at this one, I want to graph this time. This is in a slope-intercept form, so it's got a y-intercept right here of 1. So I plot that, y-intercept of 1. And then right here, it's got a slope of negative 3/2, so I go down 3 over 2. And I can keep that pattern going, down 3 over 2. Sometimes it's nice to have extra points in here. You really technically only need 2, but having extra helps you graph the line in a little bit of a nicer fashion. Okay. The next one's in standard form. Standard form, you want to find the x and the y-intercepts. And hopefully you can do this in your head at this point. Like if I said, okay, right here, can I solve for x in my head? And hopefully you go, oh yeah, it's a negative 2. That's the ordered pair negative 2, 0. Okay? And then if I did the same thing with this guy, if I plugged a 0 in for x and said, oh, can we solve for y in our heads? Hopefully you go, oh, yeah, that's a 4. So that's 0, 4. Okay? And just with those two ordered pairs, we have enough information to graph this line. So let's plot those. Negative 2, 0. 0, 4 right here. And now I can even see the slope. It's up 4 over 2 or up 2 over 1. And I can fill in some more points here in order to make this really accurate. Okay? If I look at the next one, this is point slope form, so we have to interpret that point. Remember, the equation has minus signs in it, so it's showing me the opposite of the point. So the ordered pair that it's giving me is a negative 1, positive 1. Right here, negative 1 for x, positive 1 for y. I do the opposites of those, and the slope is that negative 1/2. Okay? So I plot the point, negative 1, 1, and now a slope of negative 1/2 is down 1 over 2. Down 1 over 2, down 1 over 2, or up 1 back 2. And that's it. Okay? If I look at the next one, this isn't in any of our formats, okay? And so if it's not in any of our formats, I've got to move some things around to get it in one of our formats. And probably the easiest thing to get to is slope-intercept form, because to do that, you just solve for y. So here, let's divide each side by the 2. Let's solve for y, which gives me y equals a 1x minus 2. So now I have the y-intercept of negative 2. I have a slope right here of 1 over 1, so up 1 over 1, up 1 over 1, up 1 over 1. And that's it. If I look at this guy, y equals a number is always a horizontal line, just like x equals a number is always a vertical line. So I go to the y-axis at negative 2, and just draw a horizontal line, and that's it. And again, when you think about the ordered pairs on here, the y value stays at negative 2. And that's why I go left and right on this line. Look at the ordered pairs here. This has a y value negative 2, y value negative 2, y of negative 2. They all have y values of negative 2. That's why y equals negative 2 is a horizontal line. Okay? And then if I look at this guy, once again, this is point slope form. So to find the point is, remember, it's the opposite of this guy is a 3. The opposite of this guy is a negative 2. And now I can see the slope there is a positive 2. That's like 2 over 1. So 3 negative 2 is right here, and now up 2 over 1, up 2 over 1. Okay? Okay?